Okay, so final example. We have a fraction and the numerator is a polynomial of degree 2. The denominator is a polynomial of degree 3, so that's fine. But the denominator is not factorized. So what I can see straight away is I can take out a factor of x. Because every term has an x in it, take out a factor of x, and this is like x times 10x squared. Take x times x, take x times 3. And now this part here is what I'm going to factorize. So, magic x, because I can see that it's not 1 times x squared, it's 10 times x squared. Ooh, weird, but we can deal with it. So, first coefficient is 10. Final term here is negative 3. 10 times negative 3 is negative 30. And this is a coefficient of negative 1. So I want two numbers that multiply together to give negative 30, but they add together to give negative 1. Well, how about negative 6 times 5? Looks pretty, looks good. So we have negative 6 times 5. And then we divide both of those numbers by the leading coefficient. Divide by 10, divide by 10. Simplify it. Negative 6 over 10 simplifies to negative 3 over 5 when you divide the top and bottom by 2. 5 over 10 simplifies to 1 over 2 when you divide the top and bottom by 5. So now this gives us our factors. Our first factor will be 5x. Take 3. Our second factor will be 2x plus 1. Okay. So far so good. Just make a bit of space and we'll get into it. We don't have to factorize the numerator. In fact, it's best if we don't. So we'll have the numerator is there. Okay. Now we have 3 factors. Not 2 factors, but 3. So we express this as a constant over the first factor plus another constant over the second factor plus a third constant over the third factor. So we've split it up. So I multiply everything by all 3 factors. On this side here, all 3 factors get cancelled out when I multiply. For the first term, the first factor gets cancelled out, but those other 2 factors stay intact. Okay. Now, for the second term, Second factor is cancelled out. We're left with the first and the third factor. Okay. And for the last term, the last factor is cancelled out. We have the first and the second factors. Okay, now we have to expand these brackets and see what we get. So we have C1 times 5x times 2x is 10x squared. Then we have minus 3 times 2x is negative 6x. And 5x times 1 is 5x. And negative 3 times 1 is negative 3. Then we have x times 2x is 2x squared. X times 1 is x. So we went bang, bang. And now we do some more banging. So we say bang, bang. X times 5x is 5x squared. X times negative 3 is negative 3x. Okay, now in this first set of brackets I can do some cancelling out, get some like terms together. I have negative 6x plus 5x makes negative 1 times x. And then what I'm going to do for all of these is I am going to go ahead and collect the different terms. So first the quadratic terms. C1 times 10x squared. So we have 10 times C1 times x squared. We always write the letters in alphabetical order, put the numbers first. Then from the next set of brackets we have C2 times 2x squared. So that's 2 times C2 times x squared. And then from the last one we have C3 times 5x squared. So that's 5 times C3 times x squared. Those are all the quadratic terms on the right hand side. Now for the x terms, the linear terms, we have C1 times negative x. So we can think of that like negative C1 times x. C2 times x. And negative 3 times C3 times x. And then finally, we have just one constant term. See, there's no constant term here or here, but there is here. It's negative 3 times C1. So this is quite big. We have the quadratic stuff. Quadratic, 1 times x squared. Quadratic on the left. Quadratic on the right. And then we have x term on the left. X term on the right. And then we have constant term on the left, constant term on the right. Right. So this gives us 3 equations. The first equation is the quadratic stuff. There we go. And we can go ahead and divide everything by x squared. So divide by x squared gets rid of that, and that, and that, and that. There we have it. So 10 times C1 plus 2 times C2 plus 5 times C3 makes 1. And then what we can do is we can take the x terms. So that's one equation. So there we have it, 3x, and all this linear stuff here. Divide everything by x. Get rid of that, and there, and there, and there. And now we have 3 equals negative C1 plus C2, take 3C3. And then finally, we have our constant equation. And the constant equation is 1 equals negative 3C1. So we have 3 unknowns and 3 equations. I can put in here, if negative 3C1 equals 1, divide everything by negative 3, and C1 should be negative 1/3. So I can put that in here. I can say 1 equals 10 times negative 1/3 is negative 10 over 3. So I've substituted in the value for C1 over there. I'm going to substitute it in over here as well. Negative of negative 1/3 is positive 1/3. Okay. And now over here I'm going to add 10/3 to both sides. 1 is 3/3, so 3/3 plus 10/3 makes 13/3. Whoops, not 2x. We are done with x's by this point. So that's one equation. And then over here, I'm going to subtract 1/3 from both sides. 3 is 9/3. So 9/3 minus 1/3 is 8/3. Okay. So probably the easiest equation to rearrange is the second one. If I add 3C3 to both sides, it'll get rid of that, and I'll make C2 my subject. So then over here, where I see C2, I can swap it out for whatever C2 is over here. So I add 3C3 to both sides. So that's what I'm going to substitute in. And that comes over here. And I'm going to go ahead and write that over here so I have more space. Okay, so I'm going to expand the brackets, so 2 times that, 2 times that. So 2 times 8 makes 16, so we have 16/3. 2 times 3 makes 6, so 6 C3. and those two come together to make 11c3. And what I'm going to do is I'm going to subtract 16/3 from both sides to get rid of it here. So 13/3 minus 16/3 makes -3/3, and -3/3 is -1. So -1 equals 11c3. Divide both sides by 11, and c3 will be -1 over 11. So we're getting there. We're getting there. And now we want to work out c2. So I have 8/3 plus 3 times -1 over 11. That makes c2 according to this. Now, let's make them fractions out of 33. So I'm going to have eight over 3 equals something over 33. I have to multiply by 11 to get 3 into 33. So I do the same thing on the top. And then I have -3 over 11 equals something over 33. I have to multiply by 3 on the bottom. So I take -3 times 3 makes -9. Then I have 88 over 33. Take 9 over 33 is 79. So C2 is 79 over 33. And now I have C1, C2, and C3. And I'm going to make some space so that I can write my final answer. Okay, so I'm taking the integral of -1/3 over x plus that taking the integral of all of that with respect to x, and this becomes -1/3 times ln x plus 79 over 33 times ln 5x minus 3. And don't forget to divide by the derivative of what's inside the bracket, so we're dividing by 5. Plus -1 over 11 times ln of 2x plus 1, and don't forget to divide by the derivative of what's inside the bracket, which is 2, plus a constant. Always, always, always. Okay, so that was intense, wasn't it? Let's look at another example.